A ship travels west at 25 knots, and remember that means nautical miles per hour. At 7:30 p.m., the captain sees a floating beacon due south of the ship. By 9:15, the captain sights the beacon at a bearing of south 32 degrees east. What was the distance from the ship to the beacon at the time of the first sighting round to the nearest nautical mile? These are often best approached with a picture. So let's think about what's going on here. A ship is traveling west, so due west. So we've got our little compass situation. And we're traveling due west at 25 knots, so heading west. There's my boat. At 7:30 p.m., the captain sees a floating beacon due south of the ship. All right, so due south would be straight down, because remember, here's north, south, east, and west. So due south, there's a floating beacon. Okay, so there's my beacon. Such artwork. By 9:15, so the boat's still sailing west. So now the boat has sailed on and it's here. And when the captain looks back at the same beacon, he's got a new bearing on it. Okay, so here's the ship. And looking back at the beacon, we've got a sighting of 32 degrees east of south. So we want to draw a new compass orientation from here to indicate that direction, or that bearing, if you will. So starting at south and then go 32 degrees to the east, that tells me this angle here is 32 degrees. All right. What was the distance from the ship to the beacon at the time of the first sighting? So here's the ship, here's the beacon. We want to know this side length right here. All right. Well, if you'll notice, this is a perpendicular. So we have a right triangle situation. It may be that we can use right triangle trigonometry to solve this. But we don't really have information on our triangle yet, so let's see maybe what we left out and what we can put on. We know we were traveling at 25 knots, which means 25 nautical miles per hour. 7:30 was the time of the first sighting. 9:15 was the time of the second sighting. So that is 1 hour would get us to 8:30, and then to 9:15 would be 45 minutes, which is the same as 1.75 hours. So if we're going 25 nautical miles per hour for 1.75 hours, then we know that we could multiply this by 1.75 hours. Hours are dividing out, and that's going to leave us with nautical miles. So 25 times 1.75 is 43.75 miles. All right. So that's going from here to here, because that's the first sighting, and then that amount of time transpired to here. So we know this side is 43.75 miles. We know that this angle, if this is 32 and this is a right triangle, which it should be, then this should be 90 minus 32 degrees, which is 58 degrees. We're looking for the opposite side. We know the adjacent side. This is setting up for tangent. So we have the tangent of 58 degrees is equal to opposite we don't know, I'll give it a letter. I'll call it D for distance. D divided by 43.75. Well, when we multiply by 43.75 on both sides, we find that D is equal to 70 nautical miles. So, looking back to here, when we first were looking at the beacon that was due south, the boat was 70 nautical miles from the beacon.